As you probably know, Entagma really loves to deal with yarns. And we did a lot of yarn effects in the past, embroidery and knitting and simulations. And today we will add one video to this series. We'll talk about crochet. To generate a procedural crochet-like effect, I want to make use of a property of meshes. The fact that the Delaunay triangulation of a mesh has a dual diagram, the Voronoi diagram. So Voronoi and Delaunay are twins, so to speak. One can be transformed into the other, and we will use this fact to create a procedural model that allows for smoothly blending between the one and the other. So let's directly dive in and get started. First, lay down a geonode and rename it Crochet. Let's dive inside. Inside, delete the file swap. Instead, let's create a grid. And instead of the 10 units it has by default, let's shrink it down to 5 by 5. And let's give it some more subdivisions, as these will come in handy later when we want to remesh it. Now append a remesh node. If you connect this, it gives a very boring result. And that is because at the moment the remesh has just a fixed length parameter, 0.2, so it tries to generate triangles of the same size everywhere. We want to change this. We want to use the adaptive mode, and the adaptive mode allows for specifying the size of the triangles directly. We can use an attribute for this. So lay down a point VOP, and put it here between the grid and the remesh, and name it set target mesh size, as target mesh size is an attribute that is understood by the remesh to specify the size of the triangles. Let's dive inside. We want to create a noise to drive the target mesh size. So let's do this by laying down an anti-alias noise, connect it to P to generate noise. We can quickly pipe it here into CD, and let's make the set target mesh size visible to see what we are doing. And you see this weird result here, and that is because anti-alias noise generates values in the range between -0.5 and 0.5. So a lot of colors here on our mesh are negative, and that is these dark black spots. To change this, let's fit the result of the anti-alias noise to move it to the 0 to 1 range. So input is -0.5 to 0.5. Output will be 0 to 1. If we connect this to CD, you see now it looks better. To be able to art direct this, let's put down a ramp parameter, call it ramp noise, and ramp type will be spline ramp. And let's connect it here. And now we have this spline ramp parameter that defaults to 0. But if we go up with this value here to 1, we see an unchanged result. But now what we can do is we can just increase the contrast of our coloring by increasing the contrast of this curve. And finally, we want another fit operation at the end, because this is just values between 0 and 1, but we want to be able to directly specify exactly the values that should be used for target mesh size. So let's go to this fit to and promote the destination min and the destination max parameters. These will be our minimum and maximum target mesh size. Last but not least, let's bind export target mesh size and connect this here to the input. We can remove the CD connection because this was just for debug purposes. And if we now go to the remesh, you see that it is working. We have areas with very small triangles and we have areas with large triangles. But at the moment the values are 0 and 1. Let's use more reasonable values like 0.1 and 0.6, say. Now we have areas with small triangles, areas with big triangles, but the triangles are sort of skinny. We can change this on the remesh node if we up the iterations. Let's up the iterations to 2 and that already gives a more even result. If we use 5, the triangles are more beautiful. So let's stick to this. Okay, time to import a texture, because what we eventually want to do is to blend between two different effects, and we want to specify this blend just by color. So lay down an attribute from map node, connect it here. I already created this texture here in Photoshop. You can use whatever you want as long as it is black and white. In my case, I'll use a blurred N. So let's load this in. First make attribute from visible. Now go to the file picker and let's use nblurred, accept. And you see that it is upside down. So go to the image settings and say invert U. Now it's correct. Now we have our color on our mesh. What we have so far is a Delaunay triangulation of our mesh, and that really works on all input meshes that you might want to use. But the effect depends on the dual diagram to the Delaunay triangulation too. So let's create this next. Put down a divide sub and connect it here, make it visible. The divide sub has this nice option, compute dual. And as soon as you do this, you see that you create the dual mesh, in our case a Voronoi diagram, based on our Delaunay triangulation. And if you template the Delaunay triangulation, we can have a closer look, and we can understand what's happening here. So the points of the Delaunay triangulation here are the center points of the Voronoi cells, or the Voronoi primitives. And the points here of the Voronoi diagram are the center points of the Delaunay triangles. So that is what dual means. The Voronoi diagram is created by finding the center points or the centers of mass of these triangles and connecting these. And that gives these honeycomb structures. So now we have two representations of the same mesh. One is the Voronoi diagram, the other one is the Delaunay triangulation. The next step is that we want to make the triangles of this Delaunay triangulation animate, driven by the color. We want them to shrink where the color is white and to stay where the color is black. So let's do this next. To be able to shrink them, we need the centers of the polygons. And although the centers can be computed, they are not present by default. So lay down a primitive wrangle and connect it here to create a second geometry stream. And let's call this set my center. And this is a very, very simple wrangle. Just put in there v for a new vector attribute at my center. That is the attribute I want to create, and this should be at p. And as we are inside of a primitive wrangle, this will run over all the primitives, and add p refers to the very center of the primitives, not to the point position, because it's a primitive wrangle. So after this operation, make it visible, go to the geometry spreadsheet, you will see here on primitives we have the myCenter attribute, a vector that specifies the center of all the primitives. The next step to be able to animate these triangles is to split them up. At the moment we have a mesh of triangles, so all the triangles are interconnected. That is not what we want. We want individual triangles to be able to move their points and make them shrink. To do this, we can use a handy node called vertex split. What vertex split does is it looks at a vertex attribute, and whenever this vertex attribute changes more than a given threshold, it will duplicate the points of the vertices to create unique points, and thus create enough points to hold all the differences in the vertices. We can make use of this by creating a vertex attribute and using it with a vertex split. And the vertex attribute to use is just myCenter, because all the vertices associated with all these primitives have the same myCenter attribute. That means between two vertices here, between two neighboring triangles, we have a jump in the attribute myCenter, and this will result in a split, so it will duplicate the points here. That is exactly what we want. So let's promote our attribute with an attribute promote. Let's promote my center from primitive to vertex level. Let's quickly check, and we see no attribute on primitive level anymore, but we have it on vertex level. And of course, all the vertices belonging to one triangle have the same value now. And now we can append vertex split and use my center as an attribute. Like so. Not much has happened visually, but if you middle click here on this attribute to promote, you see we have 1,421 points, and after the vertex split we have more than 8,000 points, because now all the faces are split up. We can check if this is the case by using a node called exploded view, and if we append it here, we see that all the faces are individual now. Get rid of the exploded view. Now we can write a little vex snippet to make these faces shrink based on the color value. But before we do so, we want to store the current point positions. And that is easy because there is a default node for that called the rest position. So append a rest position that stores the current position of the points in an attribute called rest. And now append a point wrangle. And this point wrangle will be called move to center, because that is what it is intended to do. Go to the expression field here, press Alt-E to open up the code editor, and let's implement this. We have two attributes on the points. My center, which is a center here of the primitives, and then the rest position, which is the point position of the points currently. And we want to do a linear blend between these two values using the color. So let's first create a new variable of type float, just for convenience, called factor, and let's make it the red channel of CDX, like so. And now the new point position should be a linear interpolation between my center and rest. So vector my center times this vector plus rest, and you don't have to specify a v with rest because it is a standard attribute, times the reciprocal value of vector, which is 1.0 minus vector, like so. This is a formula for linear interpolation. Apply and accept. And if you make this visible now, you see that you get this garbage here, and that is because we missed one important step, and that is to go to the vertex split and to check promote to point attribute. Because at the moment, my center only lives on vertices, not on points, but this node is capable of just promoting the attribute to point level. As soon as we check this, we get the intended result. If you disable this template here, you see, let's put it in wireframe mode, you see that it exactly does what it is supposed to do. So it shrinks our triangles here to the center that we saved based on the color. So now for the Voronoi side of things. Here we do pretty much the same thing with some alterations, because this works a little different. First, we again want to create my center. But this time we want to do it before we convert it to Voronoi here, and we want to use a point wrangle for this. So lay down a point wrangle, and let's name it set my center. And it will have exactly the same code as this one, but this time on points. Because the points of the Delaunay triangulation here are the centers of the Voronoi cells. So we can just use them. And fortunately, the divide sub will use the point attributes that are incoming to swap them to the primitives. So if you check here on the geometry spreadsheet on primitive level, you will find my center here on primitives, although it has been on the points before, because it will be swapped by the divide sub. So the next thing can be just copied. We copy the attribute promote, the vertex split, and the rest. Let's copy all these three nodes over to the other side, because we do exactly the same thing now that we have the attribute myCenter on the primitives. We can use it to promote it to vertex. Then we can do the vertex split and we can append the rest. Let's quickly check with exploded view if this worked. And it worked. Great. And we can copy the move to center to the other side too. But before we use it, we have to do one more thing, because the color here on this side is on primitive level. That is due to the divide sub 2. It not only promoted myCenter to primitive level, it promoted color to primitive level too. So we have to promote it back. So let's create another promote. Attribute promote, append it after the rest, and just state CD here. We want to move it from primitives to points. Now we have it on point level. And now we can append our move to center. And it just works. But we have to change something, because at the moment both work the same. So the black areas stay and the white areas go away. But with the Voronoi side, we want to have exactly the opposite effect. That's easy. Just use the reciprocal of color. So 1.0 minus the color for this side. And here on this side now, we have the dark areas go away and the white areas staying. And now we can merge the two streams. Just merge both using a merge node. And you see now that we do that, we get a blend effect. Because both sides use exactly the same center values and the same color values to drive the effect. And that means that we get this very nice transition area here. And the larger the blur is of our texture, the larger this nice transition area will be. But this is two meshes, not interconnected. And to render it as lines, we want to append a convert line, which will just take all edges of the incoming polygons and convert them to 2-point lines, like so. And now we have a very beautiful mesh blend between the Voronoi diagram and the Delaunay triangulation. Let's append a color to get rid of the black and white coloring. And you see here you have the effect. Okay, we are done. But as a bonus, let's animate this. To animate this, we need a node that operates on the incoming color. So a node that will be appended here after the attribute from map. And we want to write a little wrangle that will cycle these colors. And as soon as these colors cycle, our effect will cycle. So lay down a point wrangle and call it cycle color. And let's append it here after our attribute from map, make it visible. Now press Alt-E to open the editor. And the first thing we want to do is we want to import a value from a GUI element to be able to influence this. So let's create a variable of type float called factor. And let's import a channel value. And the channel will just be named factor to like so. Apply this, and now you can press this little button here, and the factor input will be created. The next thing is that we want to create a variable called value, and that will be our incoming colors, so CDX, plus our factor. So what happens here now? As long as our factor is 0, the color will not change. And if we up our factor, this value will be added until it reaches 1. And in this case, everything that used to be 1 will be 2, and all the black areas will be 1. But color in the range of 1 to 2 is not very useful. So let's remap it. Whenever the value after this operation exceeds 1, we want to remap it. So let's write an if statement. If value is bigger than 1, then we want to do something, so brackets. And in this case, we want to fit it. So value will be fit of value, but we want to fit everything that is between 1 and 2 to the value range 1 to 0. Not only that we want to bring it down to the range 0 to 1, but at the same time we want to invert it, like so. And now we have to set the new CD value. So add CD is set value, value, value. And that's it. Apply this and accept it, and let's try it out. And if we now move this, you see that the colors are switching. So now we can smoothly invert the colors. And as we are able to smoothly invert the colors, by making the last node visible, we can smoothly invert our effect, which is pretty neat if you ask me. So thanks a lot for listening. I hope you learned something, and see you next time. Please let me thank all of our patrons, especially Mohammed Alabri, Mikhail Ivanov, Rob Bryant Jr., Refik Anadol, Chris Hubbard, Nick, John Kunz, and Joseph Howerton. Thanks so much for making all of this possible.